All right, guys, here we go. Kinesiology 231. This is video number 4 regarding flexibility, and specifically, this is different types of flexibility as denoted in the book. They do a pretty good job of juxtapositioning active, passive, static, and dynamic. They also do provide some insight regarding ballistic and PNF protocols. I'm going to get a little bit out of sequence in this presentation relative to the book, just because I think there's a couple bullet points that we could derive a little more benefit from if we have this out of sequence. So if we look at this, we go and jump into the active versus passive mindset when it comes to stretching. Active stretching is when the person who is stretching the muscle is also providing the force. So you can just imagine you're seated on the ground, you're doing an L-sit or doing a hamstring and a modified hurdler, and as a result, you're leaning forward and you're stretching your own hamstring. When somebody else gets involved with the process and they are perhaps the participants on their back and you're doing a hamstring stretch while you are pushing against the calf, I'm sure you've seen it done 1,000 times, that becomes a partner stretching protocol, and the partner is the one who is providing the force to make the stretch happen. And the book outlines this in terms of active versus passive, which is great. But I'm going to say, what about gravity, right? And if we take that paragraph and we parse out one particular sentence, for example, during a sitting toe touch, a client supplies the force for the forward lean that stretches the hamstring and low back. That's great. But I would also say, when I'm leaning forward and reaching for my tongue of my shoe as I'm stretching my hamstring, I also have the benefit of gravity pulling my torso down to the floor and causing what is in essence a bit of a passive stretch with gravity helping me. It's not as though somebody's hands are on me and actually pushing down, but gravity is helping. And I will heighten this when I put somebody on an incline bench. Now we use an incline bench at different angles, so we change how the resistance feels to the muscle, so we get a different response, and we're changing our position relative to gravity. That makes sense. We can do the same thing for flexibility if we use an incline bench on one notch and have the person sit on the bench, lean forward, and they're now using gravity downhill, so it becomes basically a decline, using gravity to help them pull their torso further downhill. So you can make a stretch that is in theory active because nobody has their hands on the person, a little bit more passive when you start to include gravity. Now let's use this as an example. In this video, we're doing an upper body clamshell. Lower body stands still. We're going to open up the arms and bring the arm over. When the arm is over on one side, we have to use muscular strength to bring the right arm up and over. Once the right arm is over the shoulder, there really is a net zero effect, if you will, in terms of gravity. But when you open up the chest and now bring the arm further over, you now have gravity as a benefit. It's a driver to that flexibility movement. So in that position, the person who is stretching here, they have gone from where you're using the muscles in the shoulder on the right side to help bring the arm up and over, and then you really don't have much activation from the shoulder as gravity pulls the arm down. And when you get to maybe this position, like I said, there's really not much going on when the arm's straight up and down. Now, when you bring the arm back from that position to here, you're going to have a little bit of chest work. But the point is, gravity can become our friend in stretching if you use it correctly. And it kind of comes down to this: the position of the position of the person matters, and the purpose and what you're trying to stretch also matters. So you have to be able to kind of view gravity as a tool when it comes to stretching. Let's get out of here. All right, so the book does make a few suggestions regarding stretching in general, that a warm-up is prudent. And what matters in a warm-up is, if you're going to be doing dynamic activities, you're going to do a dynamic flexibility protocol. And if you're going to do static, then you're probably going to do static training after the training session. Boy, if that isn't a quiz question written all over it, I don't know what is. And when you evaluate this, I will tell you that when it comes down to doing a warm-up for my athletes, we will oftentimes do a technique warm-up that is based on running technique drills, that is a global warm-up that gives greater potentiation, gives activation of the central nervous system, allows the athletes to be able to warm up globally, but also specifically to what we're going to do as we transition the skill from running technique warm-up to a low-level plyometric or agility drill to a higher-level plyometric or agility drill, and then to the practice environment when they're with their people or with their coaches. So it becomes this kind of continuum of movement that you have to evaluate and look at, and then be able to effectively implement with your people. By people, I mean your athletes or your clients. So I look at this and say it's part of a much bigger process. It's not as though you just show up and you start doing box jumps. You know, you do some type of activation and potentiation on the front side to be able to get the central nervous system and the peripheral nervous system working, get them neurologically hot, get a global warm-up going, and then they're off to the practice environment. So ballistic stretching, and this is another one where, boy, if there's a quiz question written anywhere in here, here it is. With ballistic stretching, it involves a rapid bouncing movement pattern, and this is usually done when the muscle is at maximal length. So you can't do ballistic stretching when there isn't tension on the muscle. There has to be tension on the muscle, and it has to be a maximal length. The book notes there are 3 limitations to this. You got where you can possibly overstretch through the ballistic movement pattern. You have greater energy requirements and activation of the stretch reflex, which is a protective mechanism to keep us from injuring ourselves if we overstretch. Now, the stretch reflex is dependent upon 2 main sensory organs, and those are 2 that are placed in 2 different areas of the body, one of which is muscle spindles and the other is GTO, and those are in the tendons, Goblet tendon organ. And what happens is this: depending upon which one is activated will drive the response. With muscle spindles, you have the neuron itself, and it's a motor neuron that senses that the muscle is being stretched too quickly, and it goes into protection mode. The GTO, that is actually at the junction between the muscle and the tendon, the musculotendon junction, and that has a different response when activated. Now, when you look at, there's the GTO, sorry, second late on clicking at. When you look at this, both of them are taking in information. So they're both on the afferent side of the equation, where they're both sensory side of the equation, to cause a myo or efferent response. So as you do this and you look at muscle spindles, those are in the center of the muscle, and when they are upregulated and they are activated, they cause the muscle to contract when activated. So muscle spindles cause contraction. I also loaded up an article here for you guys if you want to go ahead and jump out to more information on muscle spindles. Now, when we look at GTO, conversely, we know it's at the musculotendon junction, but what happens is when that is activated and you have this mechanical receptor that reads that the tendon's being stretched too fast, it'll cause the muscle to relax. So if we think of this in terms of we're looking at working with people and trying to work on their flexibility and be able to get them stronger and also be able to move more fluidly, if they are too tight and they have the mechanical receptors that are in either the muscle or the tendon are not programmed, if you will, or trained to understand movement, or what should be appropriate movement, they will go into protection mode. And you see this so often, like when somebody does have like a back injury and you can see them walking in sideways because their body has gone into full protection mode. That would be the overactivization of muscle spindles, right? It's because you're just overly contracting on one side of the equation. Now you also have the tendinous side causes relaxation in other areas, but just understand that when you have muscle spindles activated, contract. When you have GTO activated, relax. All right, so let's think about this for a moment. You have somebody who's gone through a workout and they have a functional range of motion that would be appropriate for their body. They're doing a bicep curl, but they only do a partial bicep curl. So the functional range of motion is much shorter. So anytime you go beyond what they're accustomed to, you'll have the potential to have the muscle spindles or the GTOs say, wait a minute, you're going too far or you're going too fast. That's another part of the equation. But for sake of this conversation, you're going too far. We need to shut you down. And you end up having this situation where you have to train your people to work through a functional range of motion so you don't have this response. In essence, you're trying to get your body or the body of that person to understand that they can work beyond this range of motion, not only comfortably, but safely. And you can take the body out of protection mode. And as we'll see when we get into dynamic warm-up, that whole process is low-level plyometrics and trying to shut down that stretch response. So let's go ahead and take this a little bit further. If we go into PNF, PNF is a way to help down-regulate, if you will, the GTO. And you're trying to work with the person and you'll use a hold and relax or contract and relax variation. You have it where it's a partner method, and in this partner method, one person is being stretched while the other one is helping them stretch. So let's go back to our hamstring example. You're having the person stretch, you're holding a stretch for them, then the person who's being stretched will contract their hamstring, try to push against the person who's doing the stretching, push, 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 and then relax. Push, 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 relax. And the sequencing on that can be anywhere between 1 to 2 second transition, a 6 second contract, a 15 to 20 second stretch. You'll see different protocols if you go out and research this, and the book has some pretty specific ones in the book itself, which I'm not going to focus on too much because there's so many different variations. But really what you're after is you're trying to get a partner stretch where it's contract, relax, or contract, relax, antagonistic muscle group, contract, relax, etc. You're trying to basically get the body to downregulate that GTO response. So with PNF, I put an article in here for you guys if you want to jump down this rabbit hole, but you'll see that there's correlations and relationships between overall flexibility and PNF. And it's a wonderful protocol. It's a great protocol to work on with your clients because now you get to be very hands-on with your clients when you stretch them out. So I'm going to end this video right here, and we're going to jump into more technique warm-up in the next one.